Question 1. Using nodal analysis, find V0 in the circuits below. For circuit A, we can see that I1, I2, and I3 is in the same direction, so we'll get the first equation I1 plus I2 plus I3 equals to 0. To find I1, we know that I equals to V divided by R. So I1 is here, okay, referring to this blue circle here, so I1 is the difference between V0 and 12 volt divided by 4 ohm. To find I2 is here in the orange circle here, so I2 is V0 divided by 6 ohm, whereas I3 is V0 minus 10 volt divided by 2 ohm. So we'll get the second equation. After we finish solving the second equation, we'll get the final answer V0. So we can multiply the second equation by 4 to get rid of this denominator 4. So we'll get this equation, and then we can multiply this equation by 3 to get rid of this denominator 3. So we'll get this equation. Next, we need to sum up the V0 here, and then move the negative 36 and negative 60 to the right side. So we'll get 11 V0 equals to 96, and then final answer V0 equals to 8.727 volt.
For question B, we assign all the current first, I1, I2, and I3, and then we assign a node at this point, node X. So the solution at node X, we will have I1 plus I2 equals to I3. Then we know that I equals to V over R. So for I1, we will have 30 minus V0 over 2000. And then I2, we will have 20 minus V0 over 5000. And then for I3, we will have V0 over 4000. So since now we have this equation, we just need to simplify this equation. And then finally, we will get our V0 equals to 20 volt.
For this question, at first we need to label I1, I2, and I3. So here is our node. At node, we get the equation I1 plus I2 plus I3 equal to 0. Here is reference node. From the formula V equal to IR, we get I equal to V over R. So for I1, we get V1 over 5 ohm. This 5 ohm is from 2 ohm plus 3 ohm. For I2, we get V1 minus 3 volt over 1 ohm. For I3, we get V1 minus 4 V0 over 5 ohm. So this is our first equation. Next, we need to find our second equation by using formula voltage divider. To find V0, we substitute R1 equal to 2 ohm and R2 equal to 3 ohm. Then we will get our second equation. Next, we substitute the second equation into the first equation. Then we will get V1 equal to 2.778 volt. Lastly, we substitute V1 into the second equation. We will get the final answer, which is V0 equal to 1.111 volt. Thank you for listening.